This is where history gets uncomfortable. We are looking at stone blocks weighing up to 120 tons. Some estimates say even more. They are cut into irregular, interlocking shapes so precise that not even a sheet of paper fits between them. And they were built by a civilization with no iron tools, no draft animals, and no wheel. So here's the real question. Not is this impossible, but how did they do it? And why do we still underestimate them? Before we go deeper, I can see many of you watching these deep dives, and I'm truly grateful. But only about 1% of viewers are subscribed. If you enjoy calm, intelligent explorations of ancient mysteries, please subscribe, like, and tell me what site we should investigate next. Perched above Cusco at nearly 3,700 meters above sea level, Sacsayhuaman dominates the Andes. At first glance, it looks like a fortress, but engineers see something else. Each stone is unique. Some have 12 or more sides, no mortar, no filler, just precision. This style is called polygonal masonry, and it wasn't decorative, it was defensive. The Andes are earthquake territory. Rigid walls crack, mortared stone fractures. But these walls, they move. The Quechua phrase "caninacupirca" translates roughly to walls that bite each other. During earthquakes, the stones shift, absorb vibration, and settle back into place. We have proof. In the 1950 earthquake, colonial Spanish buildings collapsed. The Inca foundations beneath them remained intact. This wasn't primitive engineering. This was seismic engineering. Precision is one thing, mass is another. The limestone quarry lies kilometers away. The andesite quarry over 30 kilometers distant. Some stones weigh over 100 tons. Today, we would use cranes and trucks. The Inca had human labor grass ropes, ramps, levers, and organization. Archaeologists estimate tens of thousands of workers were mobilized. But here's what's remarkable. The Inca didn't rush. They built over decades. Transport likely involved, wetting soil to reduce friction, shaping roads in advance, using inclined planes, gradual lifting and fitting. Was it exhausting? Yes. Was it impossible? No. But it required something modern observers struggle to imagine: mass coordination without machinery. The Inca did not have iron. Their metal tools were bronze and copper. Andesite stone is harder than bronze. So how did they shape it? The answer is patience. Hammerstones made from harder river rock were used to slowly pound the stone surface. Sand and water were used as abrasives. Repeated grinding, repeated fitting, repeated testing. It wasn't fast, it was iterative. Modern engineers call this trial fit methodology. The Inca mastered it centuries earlier. The mystery isn't that they lacked technology, it's that they compensated with time, skill, and labor. Polygonal masonry appears elsewhere. The Osirian in Egypt, ancient walls in Greece, parts of Italy. Different cultures, different eras, similar techniques. This doesn't prove a lost global civilization, but it does prove something else. When humans face earthquakes and gravity, they often arrive at similar solutions. Great engineering converges. The question isn't inheritance, it's ingenuity. Sacsayhuaman feels mysterious because we expect ancient people to be less capable. But they weren't less intelligent, they were less distracted. They observed stone, they observed vibration, they observed failure, and they refined their methods. What we call impossible may simply be what happens when a civilization commits decades to mastery. Sacsayhuaman is not evidence of lost magic, it is evidence of lost patience. It stands not as a paradox but as a reminder. Ancient people were not primitive, they were precise. If you want more ancient mysteries explored without exaggeration, follow Sri Unplugged for more.